All right, so in this video, we're going to do sort of start 4.5. The related PDF is on eCampus, so this is 4.5 simulation, and we're going to start with a dice simulation. So we're going to be throwing two six-sided dice. So let's say X is a one six-sided dice, and that would follow a uniform distribution, discrete uniform distribution that would go from 1 to 6. If you're going to simulate 1 in Python, you could do numpy.random.random integer and go low to high, or you can use scipy. Either one will work. But we want to, for this simulation, for this example, we're going to throw two six-sided dice. So let's say we have a random variable z. It's the sum of two discrete uniform random variables, x1 and x2. Let's say we want the expected value. We want to know what the expected value of z will be. So this would be the expected value of x1 plus x2. Remember back from the previous videos, this would be the same as the expected value of x1 plus the expected value of x2. And the expected value of one six-sided dice would be 3.5. And this would be 3.5. So the expected value would be 7. And this is consistent with the distribution of a six-sided dice. So I'll pull up an Excel file to show you how we can look at that. So if we add up, so along the on the row, we're going to build a matrix. This is going to be the possible outcomes for x1, and this would be all the possible outcomes for x2. And if we sum them up, so if we say this row plus this column, so this row plus this column, and we add up all of this. Let's do the copy the formula. And now we have all of the possible combinations. So for our x's, or I guess this case would be z, the possible outcomes would be a 2. You could get a 3. You could get a 4. You can get any integer between 2 and 12. So the minimum value of z would be the sum of the minimum values of x1 and x2. So the minimum value of x1 would be 1. The minimum value of x2 would be 1. So the sum of those two together would be 2. The maximum value of z would be the sum of the two maximum values. So that would be 6 plus 6, which would be 12. So we're going to count all these up. Only one combination creates 2. Only one combination creates 12. From here, we can do our probability. So there's 36 combinations total for throwing two six-sided dice. So we'll just divide by 36. We don't have to count it. We already know what it is. And then to show that this is consistent with what we did in the whiteboard, I'll do a sum product. So this is just like the dot product in NumPy. We'll multiply all of the possible values with the probability. So a probability weighted average, and it should be 7, and it is. So this is it's consistent. It is still consistent with what we were doing. So go back over here. So what we're going to do is simulate this. So we're going to simulate. Maybe we'll do a. First we'll plot it out. But whenever we go to simulate this, we're going to have to. Simulate the two dice. So we'll have one. We'll have a data frame or maybe an array. So it would just be a NumPy array, and it would be all the x's. So let's say x1i plus x2i, and we're just going to sum them all up. So we'll start at 1, or I guess in Python it would be 0, and then we'll go all the way to n. This is going to be equal to an array or a column of all of our z's. And from here, we can, then after we create this column, or if we create this data frame, from here we can calculate all the unique values and how many times that they occurred. So let's start this in Python.